Okay, so let's, with the coded values and the combinations of them, treatment combinations for each run, let's find out the main effects. Look how we work. So, for example, we want to find out the temperature main effect. So for temperature main effect, we would say, we said that high, like whatever average that we have on the high, minus whatever average that we would have in the low. So that's going to be divided by the number of the observations that we have. So here, for example, when we are talking about the temperature, when we switch it, like, look at this, this is run number 1, 2, 3, 4, up to 8, right? And then this 1 means that, okay, so you don't see any A here, so here is going to be negative. So what I'm doing here is that I'm expanding. It's like reversing whatever we have done before. So I would say minus, like, for example, total temperature is going to be in the low level. Here is C, so I don't see any A, so temperature is going to be low level. B, temperature on the low level. BC, temperature on the low level. A, so means that temperature is in the high level. And then AC, A is again on the high level, and the rest we have A. You can see A as well, so it's high level and high level. So what does it tell us is that, so we want to find out the average response at high temperature. It means that whatever you have here, right, divided by 4, the number of the observation that you have, like the number of the runs, and then minus the average response at low temp divided by the 4, like whatever you have here. Meaning, so for this treatment combination, this part is very important. So when we have, like, for the first run, our response was 74.9. For second run, our response was 63.8. For example, for our fifth run, our response was 65.5. So what happens is that when we say that, okay, so get the average of on the high temp minus the average on the low temp, what are you going to do? It means that whatever you have on the high temp, so look at it and see that what was the response, like the output, and then get the average of them. Like here, I would say 65.5 plus 95.7. You see that? 65.8 plus 94.7 divided by 4. And then you would have, like, whatever you have on the low one divided by 4. So the temperature main effect here is 9.15. And it means that when we are going from low to high, like from 100 to 200, the rate of the temperature that is changing is 9.15 per unit. So that's, and it's going to help us later when we want to develop our regression model. So the main reason that one of the main reasons that we calculate these main effects is that we want to find out our regression model, right? So we want to see that, for example, for temperature, if we say that our regression model is beta 0 plus beta 1, x1, and x1, let's say, is temperature. So when we want to find out that beta 1, we need to find out this value, like 9.15. As a practice, I would recommend that you would go with them, find out the main effect of the rate and the value of the main effect of the catalyst as well. So it's like that whatever positive that you have, get the average of them, minus whatever negative, like the response at the low level, for example, for the rate that you have, get the average and then subtract them. That's going to be the main effect of that factor. So here we want to talk about the interaction. It's very interesting when you think about it. If you go with the combination and, like, when you have the interaction, you are going to multiply these the values and see that, okay, so which one is the high and the low, you will see that we will have the same methodology. So here is the two-factor interaction indicates whether the effect of one factor on a response depends upon the level of the another factor. The temperature, like, for example, the interaction of the temperature and the catalyst. We will say average temperature effect at high catalyst, and then the minus the average temperature effect and the low catalyst. So you can see that what did we do is that we would say, for example, 95.7 minus 64.8, and then plus when you subtract this, divided by 2, minus the value. So we can find out the temperature times like catalyst, like interaction, the value is going to be 90.75. Another way of thinking about an interaction is that you can say that the interaction is going to, we had this one before, both is going to give you the same answer. So the average when both factors are at the same level, because if both of them are on the low level, it's going to give you, when you multiply, it's going to give you the positive effect, right? It's going to be like the interaction is going to be on the plus sign. Minus the average when both factors are on different level, because when you multiply them, the sign is going to be negative. So both of these is going to give you the same answer.